So today we are going to start a new chapter from class 10, which is optics. Okay, so basically in this chapter we will discuss about diffraction of light. In my another video you will find reflection of light. Okay, so let us start today with refraction of light. See, when we talk about light, this chapter is about optics. Okay, optics means something related with light. Earlier classes in maybe 8, 9, 10, you are familiar with how light rays travels, and based on that maybe you already know reflection of light. Some of you maybe do not know. Okay, so that part, light is having different phenomena. One phenomena of light is something we call reflection. You will find that phenomena in my other video. In that phenomena, light ray actually travels in a plane surface or any whatever curved surface can also be. If light ray falls on that and bouncing back of the light rays is something called reflection. Here today in our video we will discuss about another phenomena of light, which is refraction. So let us see what is refraction actually. Fine. So see, refraction means bending property of light, not like reflection. It is not like that light is coming bouncing back from the surface, or not like that. Something when light rays bends, that means the bending of light rays is what we call refraction of light. So why a light rays bends and how they can get bent, about that only we will discuss. See, what happens, light can travel in the same medium as well as in the different medium also. So it is not necessary that light will always travel in one same medium. When you learned about reflection, or when you will be learning about reflection, you will see that time light is only traveling in same medium. Either it can be air, or either it can be solid, or gas, can be anything. But then refraction is something when light is changing its medium. Okay, so when light is changing its medium, it happens for different media. When light travels from one medium to another medium, so how that thing goes on. See, suppose light ray is traveling from one medium which is solid to another medium, suppose which is liquid. Light can do so, it can occur. So when it changes its medium, then light rays bends, or you can say light rays changes its direction. Why so? Why light ray does so? Before that we discuss, we need to be familiar with two more terms. These two terms we will call optically denser and optically rarer. See, there can be any matter within which atoms and molecules are tightly packed. Okay, here suppose this is a matter where all the atoms and molecules inside this matter is closely packed. For that, if light ray wants to go through this matter, they will try to resist light waves, because you know light ray is a kind of energy. Of course, light ray is also having atoms and molecules inside that, and when light ray is traveling through any closely packed matters, then they are giving resistance to this light ray. For that, light ray is facing some difficulty to pass through this matter. Eventually, its speed gets slower where the matters are closely packed. I think the matter in which the atoms and molecules are closely packed, you call that medium denser medium, right? That means the medium is denser medium. Just because the atoms molecules the light ray travels slower. Why? Because these matters are giving, atoms and molecules are giving resistance to the incident light ray. Instead of that, if there is any other matter where the atoms and molecules are like this, loosely packed. If they are loosely packed, that means it is not denser, it is rarer. Okay. For that, a rarer medium, when light ray falls on this matter, then the incident ray does not feel so much difficulty. It can get passed through that, but still if it is coming from a denser to rarer medium, so then what happens? Its speed gets faster. Okay, so as these molecules are not giving that much resistance to the light wave, so light wave can travel faster inside a rarer medium, as well as it can travel slower inside a denser medium. So keep it in mind, in the medium where the speed of the light gets slower, we call that medium optically denser, and in the medium where the light ray travels faster, we call that medium optically rarer. So is it clear that we have two types of medium, optically denser and optically rarer. Optically denser is a medium where the light travels slower, and optically rarer is the medium where light travels faster. Okay. So like this, now if you are having such kind of different mediums, then how light ray travels? Suppose this is your medium 1 and this is your medium 2, okay, and this is the surface, refracting surface, where the bending of the light will occur at this surface. So we call this surface refracting surface. Okay, so now suppose your light ray is incidenting on that refracting surface, so it will change its direction. How it will change? Depending on that, we are having three cases. Okay, first case is, this is our first case, when light ray is traveling from a optically rarer to optically denser medium. Suppose this medium is air, okay, and this medium is suppose glass. Medium 2 is glass. So air medium is basically rarer medium respect to glass, and glass is denser medium with respect to air. So when our light ray falls on that refracting surface, this is the incident light ray, what we do, we always draw a normal at the point of the incidence. So here also we are drawing a normal at the point of the incidence like this. So now as this light ray is coming from a rarer to a denser medium inside a glass medium, it will face difficulty. As it is a denser medium, all the atoms molecules are closely packed. So this incident light ray will face some difficulty to pass through this medium. Eventually its speed will get slower, like because there in the rarer medium it was having some faster speed. But when it is coming to this denser medium, of course its speed will get less, just because this medium is giving much more resistance to the incident light ray. For that, what happens? Light should have followed this straight line path. You know, light always travel in a straight line. That is the property of light. But instead of following that straight line, just because its medium got changed, from medium 1 it entered into another medium 2, it will come closer to the normal. That also why? Because here this medium is denser. So its speed gets slower, it comes towards the normal. Now this was our incidence angle. Right? The angle between normal and the incident ray is something we call incidence angle, and The angle between normal and the refracted ray is something we call angle of refraction. So I is our angle of incidence, R is our angle of refraction, and this is our normal. Here see, angle of incidence is greater than the angle of refraction. You can see that from the diagram only, right? So this is the case when light ray is traveling from rarer to denser medium. Case number 1. That case can be opposite also. Light can travel from a denser to rarer medium also, right? For that case, what will be the thing? See, this phenomena of bending of the light ray should have followed that path, but instead of that it is following this path. So this is a bending of light rays. This phenomena is something we call refraction. Okay? Okay. So for case number 2. For case number 2, what will be the result? See, suppose in case number 2, this is the glass and this is your air. Okay. So this is denser medium and this is your rarer medium now. And light ray is traveling from denser to rarer medium. So when light ray travels from denser medium and it comes to a rarer medium, in denser medium light is having slowest speed, and when it is coming to a rarer medium, its speed will get faster because their atoms and molecules are loosely packed. So they will not give such amount of resistance to the incident light ray, so they will go faster, right? So instead of following this path, light ray should go away from the normal. That means it is going faster, 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 like this. So we got a ray which is going away from the normal, like this only. This path have been followed by the light ray, and now our angle of refraction is this much. So now we can say angle of incidence is less than the angle of refraction. For this case, when light is traveling from denser to rarer medium. So always keep in mind, when light is traveling from rarer to denser, it comes towards because its speed gets slower. And when light travels from denser to rarer, it goes away from the normal just because its speed gets faster. So is it clear up to this? Next thing is, another case is there. If no matter light is traveling from denser to rarer or rarer to denser, whatever light is doing, it doesn't matter at all. The thing which matters is how the light is falling. If light incidents normally on the surface, okay, light rays incidence normally on the surface means the angle of incidence here is 0 degree. So the refraction of angle of refraction will also be 0 degree. That means the light ray will go like this, undeviated. The term is undeviated. That means the light ray will not get shift or light ray will not bend at all. For other cases, when it was traveling from denser to rarer or rarer to denser, it was just bending itself like this and all. But here, when light ray is falling normally on the surface, it will go undeviated through the surface. It will not change its direction. Only in the case if the light ray is falling normally. Okay? So that is what we call 3 cases of this optics when they are changing their medium of traveling. Fine. See, based on that, we are having 2 laws of refraction. As the same way we got 2 laws of reflection, here also we will get 2 laws of refraction. So let us see what are the laws of refraction. And maybe you know light ray travels faster in air or vacuum, right? If it is air or vacuum, light ray travels faster in that. 3 into 10 to the power 8 meter per second is the velocity of light in vacuum. Okay, so let us see what are the laws of refraction. refracting surface, this is the incident ray, and this is your normal, and this is your refracted ray. Then all the incident ray, refracted ray and normal will lie on the same plane. That is our first law. Second law says, if you take the ratio of sine of the angle of incidence, angle of incidence, the angle between normal and the incidence ray, which is I, and angle of refraction is angle between normal and refracted ray, which is R. Sine of the angle of incidence and sine of the angle of refraction, that means sin I by sin R. If you are going to take the ratio of this, then for a particular medium it will be constant. Is it clear? It will be okay. So for this pair of given medium, it will be constant. It will get a constant value. What is this constant value? This constant value is something we call refractive index. Okay, so this refractive index just tell us that the medium is how much optically denser or how much optically rarer. It just tells us about that. Okay, so this refractive index is something which we define with this term mu. Okay, and this is the ratio of two physical quantity which are same. So it is having no unit. Refractive index has no unit at all because it is the ratio of the two same physical quantity. Basically, when we say, this is the second law, okay, if you are going to take the ratio of the sine of the angle of incidence and sine of the angle of refraction for a given pair of medium, that will be always constant. And that also we write like this, 1 mu 2. What is the meaning of writing this? That is, when we are writing anything like this, that means we are finding the refractive index of medium 2 with respect to the refractive index of medium 1. What is the meaning of that? Suppose there are two mediums. This is medium number 1, that is medium number 2, and you want to find out the refractive index of this second medium. You do not know its refractive index. You want to find out the refractive index of this medium. See, refractive index is a constant term, okay, which is for a given pair of media which is constant. It just defines how much the medium is optically denser or rarer and all that thing. So this refractive index depends on some things and some factors. But before that, let us know what is this refractive index. When we are finding the refractive index of medium 2 with respect to medium 1, then we write it like that, 1 mu 2. Which medium's refractive index we are finding, we write it on the right side, and with respect to which we are finding refractive index, we keep it on the left side. Okay, so now we are finding the refractive index of medium 2, so we wrote it in the right side, and with respect to medium 1 we are finding the refractive index, so we kept it in the left side. Do you understand? So like that, if you are going to find the refractive index of medium 1 with respect to medium 2, you should have written it like this. Understood? Now you are getting these two types of things, refractive index. Suppose you are finding the refractive index of any medium with respect to air. What we actually do, we always try to find the refractive index of mediums with respect to air or vacuum, because we know light is having the maximum speed in air. So when we find the refractive index of any medium with respect to air or vacuum, that means when our first medium, and with respect to that, when we are finding the refractive index of the second medium, we call that refractive index is ideal refractive index, because light we are taking, the speed of light for air is the maximum, we know, 3 into 10 to the power 8 meter per second. So when our first medium is air, and with respect to air or vacuum, when we are finding the refractive index of any other media, which can be solid, liquid, like that, then we call that ideal refractive index. Okay, but we can always find refractive index of any other media. See, from here we can conclude, suppose your first medium is air and this second medium is glass. Okay, so we can write, we are finding the refractive index of glass with respect to air. Okay, we will get this, which is approximately 1.5, something like that. And if we are finding the refractive index of air with respect to glass, we will find it as 2 by 3. That only means that this two thing, mu 1 2 is equals to 1 by mu 2 1. That means they are just reciprocal with each other. Like if you are finding the refractive index of medium 2 with respect to medium 1, that will be the reciprocal of the refractive index of medium 1 with respect to medium 2, like this. Okay, so this is the relationship they maintains. If you are going to find the refractive index of the first medium with respect to 2, and if you are finding the refractive index of the medium 2 with respect to 1, they will be just the reciprocal of each other. That is the formula this refractive index follows. Is it clear up to this? Then first factor is nature of the medium. That means, what is the nature of your medium? Is it the molecules inside it are closely packed or loosely packed? Depending on that, refractive index depends on this. Then the speed of the light also increases, because if you increase the temperature inside that matter, atoms and molecules will start trying to move with more vigorously. So for that, as light is having the formula of refractive index, which is the ratio of velocities in two different mediums, ratio in the vacuum, speed in the vacuum of the light and speed in the medium in which you are finding. Okay, so these are the two ratio of the speeds which results in the refractive index. So if temperature increases, speed in that medium will also increase, and that is why refractive index will decrease, as they are having inversely proportional relationship. So this refractive index depends on three factors. First factor is nature of the medium, and second factor is temperature. If temperature increases, refractive index will decrease. And another factor is wavelength. If wavelength increases, your refractive index will automatically decrease. That means for violet light, as violet light is having highest wavelength, for that refractive index will be the lowest. And as red light is having the lowest wavelength, for that refractive index will be highest. There are two mediums, medium number 1 and medium number 2, and if your light is following a path where your incident angle, and this is the angle of refraction, if your light is following a path like this, when it is traveling from medium 1 to medium 2, then this path is actually reversible. Okay, path of the light is reversible. Reversible means, if now in the second case light travels from medium 2 to medium 1, that means from this side, if your light travels to this side in the medium 1, then also your light will traverse the same path. Okay, that means the path of the light ray is always reversible. If your light ray is going from medium 1 to medium 2 and it is following some path like this, then again if you compel the light to go back in the same way, that means if now your light ray is going from the medium 2 to medium 1, it will follow the same path it has been gone through. That means the whole path traversed by the light ray is always reversible. That principle is something we call principle of reversibility. Okay, a glass slab, okay, having some thickness T. T is the thickness of this glass slab and your light ray is falling like this. Achha, this glass slab is not like this side narrow, this side thicker. It is not like that. It's just I am a very bad painter. Okay, so like that your incident ray is falling on this glass slab. If it is does so, and if you are going to draw a normal at the point of incidence, see from air, light ray is going inside a glass. That means from rarer to denser medium. So as I said, when light travels from air rarer to denser medium, it always come towards the normal. Here it will come like this, right? Instead of following that path, it should have followed that path. See, light ray should have followed this path if there was no glass block. If you vanish this glass slab, that light ray should have followed this straight line path because light always travels in a straight line. But just because there is a glass slab in the middle of this incident ray, so when incident ray falls on this glass slab, it suffers some refraction from the first surface. So if this is a first surface, then from this first surface this light ray is suffering refraction number 1, while if it is coming from rarer to denser, ray comes towards the normal of the surface. So it was your incident ray, now it is your refracted ray and angle of refraction like this. Again at this second surface, see, again at the second surface also this light ray should suffer something refraction, of course. If you draw a normal here at this point of incidence, if you draw another normal here at this point of incidence, for this lower surface, this refracted ray is the incident ray. So there also they will suffer another refraction number 2, as it is coming from denser to rarer medium. So light ray will move away from the normal like this. Like this. Okay. So now this is our next final refracted ray. So light ray has, this ray is refracted ray, final refracted ray. Also this ray is something we call emergent ray. Because this ray is emerging from the glass slab, so we call this ray as emergent ray. Also this angle we call that angle E. That means the angle of emergence. Okay, so see here light ray, if there was no glass slab, should have followed that path, straight line. But just because there is a glass slab, the ray of light got shifted from its original path. The original path is that, and now it got shifted by this much. It is following another path instead of this, but same parallel, but got just little more shifted. So this is a phenomena which we call lateral displacement of light. Just because light is suffering some shift or displacement from its original path, so we call this phenomena is something lateral displacement of light. See here, the incident ray was going this side, it suffered first time refraction, got towards the normal, and then again at the lower surface it suffered another refraction number 2, it go away from the normal, and then again, but it is got shifted from the original path. So we call that final ray as emergent ray, and that angle we call angle of emergence, and what we finally got is the phenomena which we call the lateral displacement. That means always if there is something block or something like in the middle of the path of the light rays, then this lateral shift can happen. That lateral displacement can happen there. And also this lateral displacement is something which depends on some factors. What are the factors? If, see here, the factors are, first, number 1, if the angle of incidence is large, if you increase the angle of incidence, that means your shift will also get increased. With the increase of angle of incidence, lateral displacement also increase. Another point, factor number 2 is if your thickness increases. This much thickness is there for this glass slab. If it also increase, your shift will also increase. That means with the increase in thickness, lateral displacement increases. And increases, lateral displacement will also increase for that medium. Okay, so all these are the 3 factors on which your lateral displacement or this shift depends. If angle of incidence is less, shift will be less. If thickness is less, shift will be less. But if this angle of incidence is large, thickness is large, also refractive index of the medium is large, then your shift will also be larger. Is it clear? Okay, suppose this is the thick mirror. This surface is polished. Sorry, this one is polished, this one is silver. NQ surface is silver surface. So for that, and it is a thick mirror, as you can see. Suppose here at any point there is your source A. So what will happen from this source? Your light ray will travel and will incident on a point at the surface of the glass, the thick mirror. Right. But then some of these light rays will get refracted and some of the light rays will get reflected. Okay. So mainly what happens here, 2 cases happens. Some of the light ray will be getting refracted and some of its paths will get reflected, refracted inside the thick mirror. But some of its part like 6% or something, or maybe 4%, it gets reflected. Okay. So what happens, suppose we are going to draw a normal at the point of incidence, you will find that this light ray A, suppose it is at this point it is B, so this light ray AB will suffer a reflection at the amount of 6% here, because this is a mirror. Okay, and some of its part, that means 94% of this AB ray will get refracted. But here this is the rarer medium and this is the denser medium. So for that, when light ray is traveling from rarer to denser medium, that means the light ray will come towards the normal, like this. This is our refracted ray. The path should have been followed like this, but instead of that, it is following a path which is this. It comes towards the normal as it is suffering a change of medium. Okay, suppose this is our reflected ray and this is suppose D. Okay, this BD is our refracted ray. But here at the lower surface, when the light ray falls at the lower surface of the mirror, as this surface is silver surface, so it is strongly reflected back by this surface like this. So total BD refracted ray got reflected by the lower surface like this, and this is suppose DE is our reflected ray. So I am going to write it here, everything. AB is the incident ray, BS is your reflected ray, because I said some of its parts got reflected, some of its part got refracted, and the other part which got refracted is BD, which is your refracted ray. But again, by this lower surface, this BD ray got reflected, which is now DE. That means DE is your reflected ray. Right? Now this BD, when going from denser to rarer medium, it will suffer a refraction. If we draw a normal here at the point of incidence like this, then we will be able to see as it is going from denser to rarer, so it will go away from the normal like this. If we name it like G, D, E is not there, E, F. So you will see that your DE is the reflected ray and EF what you got is your refracted ray. Okay. Now like this, another part of this got again reflected by this. Suppose that part is G. So your EG is reflected ray. Again that will be getting reflected by this. If our mirror is extended, gets extended like this, will suppose this much. Then here again at the upper surface it will get refracted just because it is going from denser to rarer medium. So you will get HI refracted ray. Again from here it will get reflected. Another you will get here. Like this it will happen. It will occur continuously as long as this mirror is. So we will get multiple images. How we will get? See, all this we got reflection, refraction, reflection, refraction, reflection, refraction. That is the continuous process of reflection and refraction, reflection and refraction, like this. So if we want to see the images, then we will be able to see. If we extend, I am going to wipe all this, okay? No place is there just because of that. So if we are going to extend all these refracted ray like this, we will be able to see, and behind the mirror if we extend all the refracted rays, then we will be seeing that there we will get so many images of the object A. So many images of the object A we will get there. But just because is the process of refraction, reflection, refraction, reflection, because of that only the first and second image will be brighter and the next images what we will get, A3, A4, A5 like this, all the images brightness will get diminished, just because in the process of refraction we always lose energy. Okay, so energy is lost in refraction. Because of that, we will only get the first two images are having much more brightness, but other images, whatever A3, A4, A5, all the other images, their brightness will get diminished. Okay, so that is the thing of, if you are going to place a thick mirror in the path of the any light ray, it will form so many multiple images of the illuminated object here at the back behind of the mirror. But then only the first one two images will be bright and other will be having lesser brightness, just because it is this light ray suffering again and again refraction, and we energy get lost in the process of refraction. So up to this, all these were the things based on refraction. We will learn refraction through a prism also, but next day. So I think all of you understood, and if there are any doubt, you can always ask me in the comment section. I will try to clear, and please let me know what are the improvements I need to do so that you can understand it in a very well manner. And then please keep liking and share and subscribe my channel. Thank you.